So the 613 classwork, describing transformations. In lesson 612, you used words and coordinates to describe how a triangle moved on a graph. These expressions describe the starting place, the motion, and the point where the triangle ended up. Today you'll write similar expressions to describe transformations on a grid. So the first question says, Rosa changed the position of quadrilateral ABCD, this one right here, to that of quadrilateral WXYZ. How did the coordinates of the points change, she wondered. It says, describe how Rosa's transformed it. Was the shape translated, slid, rotated, turned, or reflected? Explain how you know. So this is a translation. And we know because it stayed in the same position, but changed location. Okay, so just how far did it move? It moved 6 units to the right and 8 units up. So it says, so point B, so let's go back to the graph. Point B is at 1, 2, 3, 1, 2, 3, 4, 5. Negative 3, negative 5. Point X is at 1, 2, 3, 1, 2, 3. Is at 3, 3. So D says, how did the coordinates of B change? How did its y coordinate change? Write an expression. So we're going to say that x plus 6 is our x coordinate because it moved 6 to the right, and y plus 8 is our y coordinate because, and if I add 8, negative 5 plus 8 is 3. Negative 3 plus 6 is 3. So then it says, visualize translating WXYZ 10 units to the right and 12 units up. Where will the point X end up? Without counting on the graph, work with your team to find the new coordinates of point X. So point X is at 3, 3. If it goes 2 units to the right, it's going to be at 13 because 3 plus 10, and it's going to be at 15 because 3 plus 12. So the X coordinate is moving X plus 12, and the Y coordinate is moving Y plus, oops, this should be 10. X coordinate is X plus 10. The y coordinate is x plus 12. So then it says, Rosa translated a different shape on the grid. Use the clues below to figure out how her shape moved. The point was at 4, 7, and now it's at 32, negative 2. Without graphing, describe how the shape moved on the grid. So it moved 28 units to the right and 9 units down. So it says without graphing, so it says another point on original shape was negative 16, 9. After translation, where did it end up? For each coordinate, write an expression. So negative 16 moved 28 spaces over, so it ended up at 12. And 9 moved down 9, so it ended up at 0. So my x coordinate, x plus 28, and my y coordinate is going to be y minus 9. Because we moved down 9. So notice if it's positive, we're moving right or up. If it's negative, we're moving down or to the left. All right, Rowan transformed quadrilateral CDEF to get the quadrilateral PQRS. Describe how the transformation was the shape translated, rotated, or reflected. Reflected because it flipped over the y-axis. So it flipped over the y-axis. Rowan noticed that the y-coordinates of the points did not change. What happened to the x-coordinates? Compare the x-coordinates of point D. So when we compare these, we see that, let's see, the x. So D is at negative 1, 6. And Q is at 1, 6. Okay, And then if we compared E and R, E is at negative 3, 1. And R is at 3, 1. So we can say that the x coordinate became its opposite. Can you describe the change to all the x coordinates with addition like you did in problem 618 and 619? So no, but we could use multiplication because multiplying by negative 1 is the same as finding a number's opposite. So like 3 times negative 1 is going to be negative 3. 3 and negative 3 opposites. What parts of quadrilateral CDEF are the same? Okay, and how can we tell? So they're the same because they created a congruent shape, and we could say that CD is the same as PQ. It's just going to follow around the shape. They go in the same order. So C and P, D and Q, E and R, F and S will always create the same. All right, so imagine that Rowan reflected quadrilateral CDEF from problem 620 across the x-axis instead. What do you think would happen to the coordinates in that case? Okay. So we're going to actually do it on a graph. Okay, and I'm going to look back to see what the ordered pairs were. So originally we had 3, so C was 6, 6, or, sorry, 7, 6. D was a negative 7, negative 1, 6. E was negative 3, 1. And F was negative 6, 1. Okay. So we would draw that. So C was negative 7, 1, 2, 3, 4. That was C. Alright, so here's the original, and then I'm going to change color of my marker. Alright, so I want to reflect it across the y-axis. So like E is 1 away. So I go down and put a dot 1 away. F is also 1 away. C is 1, 2, 3, 4, 5, 6. So I go 1, 2, 3, 4, 5, 6. And D is 1, 2, 3, 4, 5, 6. Break it down 1, 2, 3, 4, 5, 6. My new shapes letters are J, K, L, M. So C became J, K, L, M. Okay. So then I would have inserted that into my presentation. So then it says compare the coordinates of point C with J, D with K, E with L. So what do you notice? How can you use multiplication? So the y coordinates became the opposites. So multiply by negative 1. So this problem says, in problem 620, Rowan noticed that multiplying by the x-coordinate by -1 reflects the shape across the y-axis. Test this strategy on a triangle formed by the points -3, 5, 1, 2, and 0, 8. Before you graph, multiply each x-coordinate by -1. What are the new points? So we're going to call them primes. A prime would become 3, 5. B prime would become -1, 2. And C prime would stay 0, 8 because -1 times 0 is 0. Okay. So we have a new graph. So my original order pairs were -3, 5. One, 2, and then 0, 8. And this was A, B, and C. Okay, so now I want to change colors so that I can graph my other graph, my other triangle. So now my triangle is at 3, 5. So this is where A prime ended up. B prime ended up at -1, 2. And C prime stayed exactly the same. So it is flipped over. If we were to fold on this line, kind of like you did with Valentine's hearts, it would end up being the same answer. So it says, do the triangles reflect across? Yes, they do. Okay, this problem says, in the last 3 lessons, you have investigated rigid transformations, reflections, rotations, and translations. What happens to a shape when you perform a rigid translation? Do the side lengths or angles in the figure change? Do relationships between the lines, parallel, perpendicular change? Why do you think reflections, rotations, and translations are called rigid transformation? So a shape does not change when you reflect it, rotate, or translate it. The side lengths stay the same. Angles between the side lengths stay the same. And the line relationships also remain the same. This is why rigid transformations. When I think of the word rigid, I think of something that doesn't change. So like sometimes if a person is rigid, they're set in their own ways. So rigid transformations are set in their own ways. They do not change. All right, so it says Stella uses 3 steps to move the key on the graph below from A to B. Follow the steps that Stella wrote below. Click here to use a digital version to help you. What was her last move? Okay, so Stella moved. So if we go back here, that's our original. So Stella slid the key to the right 3 units and up 6. So to the right 3 units and up 6. So that was our first. Then Stella reflected it across the line y equals 4. Okay. So then what could she have done next? So reflect the key across line, x equals 4, sorry. We gotta change this. Exit. X equals 4. All right. So then, her last one, we could say that she didn't rotate it, that she slid it again. She slid down 2 and 1, 2, 3 to the right.